So we're told that both x and y are complex numbers and their product is irrational. So for example, it could be square root of 3 here. Questions, which of the following cannot be true? So if I look at the answer choices, both x and y cannot be rational, because in that case you cannot get their product will be rational. So F is the correct answer. If we look at the others, both x and y are imaginary. That's a possibility. So that one isn't an answer. Product is root 2. That's also a possibility. And their product can also be negative. And let me illustrate that with an actual example. So let's say I wanted this to be root 3. And I know that if I have these as complex conjugates, then when I multiply these using the difference of squares, this is a real number, and I just need to make this irrational. So the way I'm going to do this is to make a to be root of root 3, let's say that. So when we square that, a squared would be 4 root 3, because notice this is a double root here. And I set b to be 3 root 3. No, actually, I'll just set it to be, actually put the radical inside. Now when I square, b squared would become 3 root 3. And then their difference is root 3. So my x and y values are 2 root 3 plus 3 root 3. Actually, root of root 3 is kind of confusing. That's your x, and then the same thing with y with a minus here. So it's possible that will show you that you can make it root 2, again, choosing appropriate numbers. And it can also be negative if I flip these values, meaning make this b and make that one a, because then there would be a b squared minus a squared, which would be negative root 3. So it can be negative, and then both are imaginary, as I just showed you with these values. So yeah, it is a hard question in terms of maybe this may be hard for students to kind of think of what could those examples look like. Maybe there are other easier examples that I don't see it, but this is kind of how I visualize what those possible complex numbers x and y could be. But the answer is F.